All right, gang, more on linear programming. But what I want to do is I want to work, I tell you, I don't know what's going on right down here. That's going to bug me, but it looks like it's something, a malfunction with my overhead. Well, whatever. I'm sure I'll worry about that more than you. But what I want to do here is do two more linear programming problems. Now, let me tell you what's up with this problem right here. I'm going to work this problem the way I've worked all the other ones. We're going to set the objective function, set our constraints, look at our feasible region on the calculator. Now, this very problem is worked by another person. I don't know much about this person, but I certainly want to give them credit. But what they do, and I'm going to post this link as probably well, follow-up video or video 2, or I'm not really sure how it'll fall out, but you'll see that he works the linear programming problems more algebraically than I do. And this guy's name is Patrick JMT. So Patrick, thanks for putting up this video. I'm going to steal it and let my students watch it. I think he did an excellent job going through. He does mess up a little bit here in the first. He calls brand X and brand Y and switches it to brand A and brand B. But if you've been teaching very long, we've all done that. So anyway, I'm going to work this problem, and then I'm going to work another problem. And but I really do want you to contrast the two approaches. I see this as an applied course, so that's the reason I use the calculator more than I would, say, in a calculus class. He teaches it more algebraically, which is cool. It's fine. Just a different approach. All right. So, guys, I'm going to work it the way I would work this. So the first thing I would want to do is read the problem and make sure I'm recording here. Read the problem and set up the variables. So. It says a rancher is mixing two types of food for his cattle, brand X and brand Y. How much of each type, so I jump down here to the last sentence before I get too involved in all this stuff. How much of each type should be used to minimize the cost? So I'm going to let X be the, what are we doing here? We're talking about grams. So grams of brand X, and I'm going to let Y be grams of brand Y. So once I work this problem and I get down here where I've got my answer, I'll know what my numbers stand for. Now the next thing I'm going to do is I'm going to set up my objective function. So I want to minimize my objective function. And we're wanting to minimize the cost. Now this is one of the reasons I wanted to do this problem, because I don't think we've seen a minimization problem yet for linear programming. I think all of our problems have been maximization, which is pretty typical. But I wanted to do one minimum before we go on to the cool stuff. All right, so we're minimizing costs. So it looks like when I come back here, I see the costs are 80 cents and 50 cents for brand X and brand Y respectively. So I'm going to have 0.80x plus 0.50y. Now I've got to go back into my problem and get my constraints. Okay. Now it looks like each serving is comprised of protein and fat, and I get some protein and fat from brand X, and I get some protein and fat from brand Y. So I want to take, obviously, protein plus protein to get protein, and fat plus fat to get fat. So I'm getting 15 grams of protein. So this first objective function, I'm going to set up for protein. Okay. So I'm going to have 15x plus 20 from Y, and it has to have at least 60 grams of protein. So at least means greater than or equal to. The next thing I want to do is I want to set up an inequality for fat, and I can see that I get 10 grams of fat from brand X, and I get 5 grams of fat from brand Y, and I need at least 30. So I've got the 60 and the 30, and I've got my 15 and my 10, and I've got my 20 and my 5 for brand Y. Now, since we're dealing with the grams, we get the extra constraint that our values for X and values for Y can only be considered to be positive. So I enter into this, okay? Now, the next thing I'd want to do is I'd want to take each one of these and I'd want to solve for Y. So I'm going to just do a little trickery here. Not really trickery, but I'm going to go ahead and move the negative 15x across. I've got plus 60 done. So I'm going to divide through by 20. Since I'm dividing through by a positive number, I don't have to change the inequality. And you know what I get here is negative 0.15. You know, I think most of you would probably serve yourself best to change that to a decimal. So you know, if I do that, I'm just going to put in 15. I can do this in my head, but you know, maybe you can too, or maybe you can't. It doesn't not that big of a deal. And then we get plus 3. Okay. Now the other inequality is I'm going to go ahead and do the same thing. So I'm going to bring the 10x across to make a negative 10x plus 30 and divide through by 5. So I get y greater than or equal to negative 2x plus 6. So gang, I've got these two inequalities right here. Looks like my ink pen's running out of ink, but we'll take care of that. Okay, so what we need to do now is we need to put these in our graphing calculator and you know, make some stuff happen. So I'm going to do that. So I'm going to go y equal. I've got some stuff in there from my statistics course. So what do I have? Negative 0.75x. Plus 3. And I have negative 2x plus 6. Now I've got to go over here and change up my inequality. So I want, actually want greater than in both of these, don't I? Now the hard part of all these problems is coming in and getting your window. And I can see for my x's, the best way to get a value on my x-intercept is just cover up the y's. So the first thing I get a 4, and the second thing I get a 3. So the first inequality I just do mental math. I take 60 divided by 15 and I get 4. And I do mental math here. I take 30 divided by 10. So this gives me the value of x when y is equal to 0. So covering up the y is equivalent to making it 0. So my x-intercepts are going to range between around 3 and 4. Now I'm going to start this out as 0 for obvious reasons because I'm solving for the grams of brand X. So this would be, we can't have negative grams. And I'm just going to run this up to 5. Now y's for the same argument. We can't have negative y's. And my y-intercepts are really easy. They're 3 and they're 6. So I'm going to run it up just a little bit bigger than that, and I'm going to go up to 7. Guys, hit graph, and magical things will happen. A little bit annoying because I've got some lighting problems. Let me show you what's going on here. I've got some stuff going on in my stat plots, so I'm going to go turn those off. And I'll hit graph, and then I won't get that annoying box plot that's irrelevant to this problem. All right, gang, what I got to do now is I got to figure out some things. And what I've got to figure out is I got to figure out this feasible region. So my feasible region, if you look at this, is going to look like this. It's going to start here and come down, so it doesn't have to be perfect. And then it's going to go out this way. Again, what we got here is we have an unbounded feasible region. And you can see that we can only have 3 corner points that we have to consider here. Some of these are really easy because, this line right here gives me that y-intercept. And if I extend this line down here, I get that y-intercept. So I need the biggest y-intercept and the biggest x-intercept of the two. So the biggest x-intercept, as we saw before, was what? 4 and 3. So this point right here that we have to consider is 4, 0. The biggest y-intercept of the 3 and the 6, probably help if you can see this, of the 3 and the 6 is clearly the 6, which is the one we're focusing on right here. So this point is going to be 0, 6. Now, the point of intersection, now the video that I'm going to post on YouTube, where I can't remember his name, but the guy I talked about earlier, he will find that point algebraically. I allow you, because of the nature of this course, it's an applied course, to use your calculators. So second function calc, come down to intersect. And we've only got 2 lines, the first one, second one, guess. So we get 2.4, comma 1.2. All right, gang, what we do now is we're going to evaluate our points. So based on our x and our y, what's our z values? So we have a 0 and a 6 from this point, a 4 and a 0 from that point, and a 2.4 and a 1.2 from that point. All right, the guys way back when, remember our z is 0.8x plus 0.5y. So we can have our z in this case as 6 times 0.5. We can have our z in this case as 4 times 0.8. Now guys, remember, we're trying to minimize here, aren't we? We're trying to find the minimum cost. It'd be kind of wacky to do a problem where we're trying to maximize cost. And z in this case is going to be 0.8 times 2.4 plus 0.5 times 1.2. I can do that in my head, but if you can't, it's not a big deal. So 0.8 times 2.4 plus 0.5 times 1.2. And I messed up. Let's insert parentheses there. All right. So guys, we get 2.52 as the answer. So the minimum cost is going to occur when we have 2.4 grams of brand X, 1.2 grams of brand Y, and the minimum cost is going to be $2.52 to achieve our mixture, the goal of the mixture. Okay. Now let's go see what he got. Wouldn't it be kind of wacky if he ends up with a different solution than me? You can see that he gets 2.52 as well. Now, we start out the same, and you'll see if I can go here in just a second. You're going to see a lot of the similar stuff, right, in terms of constraints and the objective function. He has the objective function right up here, and his constraints from about a minute mark 3:30 up until the end that I pointed out a while ago. We do some different stuff. He does things algebraically. I do things, with the graphing calculator. So, gang, if things are going well for you and you're okay with my approach, then You don't have to watch the second example, but I think it would be really kind of beneficial if you did. If you think it's going to confuse you, then don't don't do that, for goodness sake. Last thing we want to do is make this stuff more confusing. All right, gang. Second linear programming problem on this handout. A farmer has at most 240 acres to plant. So we got something going on about acres of corn and oats. So come to the bottom. To maximize profit. So we're going to maximize Z in this case, and we need to find our profit. Now, it looks like X is going to be acres of whatever we're given first, corn, and Y is going to be acres of oats. All right, so we want to maximize Z. We're going to maximize the profit. And we see that we make $40 of profit for corn. And we make $30 profit per acre of oats. Now, I had a student one time say, well, Dr. Darbro, that's just pretty silly. Why is the person even considering planting oats? Why don't they just put all of their their focus on corn, because you get more profit per acre? Well, what happens is you see that it takes more to create the acre of corn than it does for the oats. So we have to keep everything in consideration. All right, gang. First of all, we see that we've got at most 240. So however many acres of corn we have and however many acres of oats we have can't exceed 240. And then we get into the next thing that we're given. We're talking about the labor. So it takes 2 hours of labor per acre to harvest oats, and 1 hour per acre to harvest, 2 acres to harvest corn, and 1 hour per acre for oats. And we have at most 320 hours. Well, guys, obviously we have to have positive stuff here because we're dealing with corn and oats. I've never seen a negative acre of corn. Guys, same as before. Let's solve for each one of these. So I'm going to solve for the first one, which is going to be really, really easy. Don't you love it when that happens? And then the other one is equally as easy. I don't know about you, but I just love it when that happens. Okay. All right. So we've got our two inequalities along with our constraint that these things have to be, this number of acres has to be positive. All right, gang. Let's start thinking about our x and y intercepts. I think this is a good thing to look at. So I'm going to let this one be this and this be this. X and y, well, I know this has a y-intercept of 240, and this one has a y-intercept of 320. And now if I can go back and get my x-intercepts for each one of these, well, the first one, the x-intercept is just covering up the y, so it's 240. And it's just covering up the y, and I get 320 divided by 2 is 160. So these numbers here are really nothing more than to help me set up my window appropriately. So let's get in here and make it happen. So we've got negative x plus 240. And I'll come back and get my inequality in just a second. Negative 2x plus 320. All right. So let's change this to from greater than to less than. Okay, let's get the window. So my x-intercepts, if I look down here, were 240 to 160. I'm going to go from 0 to 250. And my y-intercepts look like they range from 240 to 320, so I'm going to go, yeah, just whatever. I'm just going to choose 350. All right? So, gang, we should, that's just gorgeous. Don't you love it when that happens? So let's go see what happened. I must have done something goofy. I did. I set my y-min at, well, that was just silly. Okay, that was just careless. All right. And, you know, I see a lot of students that will do something like that. I'm kind of glad that happened, just to show you that I'm human and I do stuff like that too, although I don't think you need convincing at this stage of the game. But, you know, I just got sloppy. And a lot of times students will get that, they'll know what they're doing. They just do something silly, just like I did. And they'll get that error thing pop up, and they're just like, well, I don't know what I'm doing. Math 1700 is just too hard for me, you know. No, I didn't. You just screwed up. We all do it. Okay. So let's do our graph. And our feasible region looks like something we've seen many times before. All right. So our feasible region kind of does something. I'm going to abbreviate these just a little bit. It looks something like that. Guys, this is the easy point, 0, 0. This point right here of my two y-intercepts is the least one. So it's got to be of the 240 and 320. It's got to be 240. This point right here has to be the least of my two x-intercepts. There's one x-intercept. There's the other one. It's got to be the least of those. Well, I've got 240 to choose from and 160 to choose from. And then I'm going to let my calculator do the rest. All right, so second function calc, go to intersect. Second curve, don't need a guess because I've only got two curves. So I get 80 and 160. All right, what we got to do now is put this in our table. So we've got 0, 240, 80, 160, and 160, 0. All right, so our objective function, let's get back over here. Our objective function, this is what we focus on at this stage of the game. So we're going to have 40 times 0. I'm just going to go and put this in and show you something. And then I want 30 times 240. So I've got 7,200 there. Now I'm going to go second function entry and just go back up and change what needs to be changed. So I have 80 that needs to go there, plus 30 times, well, we got 160. Really careless today, aren't I? So we got 8,000. And the other one's pretty easy. We just have to take 160 times 40, which we can all see is 6,400. But just in case you can't, 6,400. So guys, the one that wins out is the 80 acres of corn and the 160 acres of oats. And our maximum profit will be $8,000 per acre. All right, gang, that's all I got for you. Take care.